Let's go to the code 1842. Next palindrome in same digits. For this question, it gives us string num, and it is numeric string, and this kind of number in the string, it is palindrome. So to ask, return the smallest palindrome larger than num that can be created by rearranging its digits. So what do we do? Let's take a look at, say, example 1221. The next greater palindrome using the same digits, that is 2112. And also this is also a palindrome, right? But we know this is in a descending order, right? This 332 is in descending order, so there is no next greater one using digits, the same digits, so it's returning an empty string. And for this part, 4554 and 4554, the next greater one is 5445. So what we do is that we can separate this number into two parts, the left part and the right part, right? So it's possibly there is one chart in the middle, right? So if we can find the next palindrome for the left part, then we compose the right part, and then we can return the result for the next palindrome of the whole string. So for the left part, it is similar to the question of next permutation, right? So what we do is that from the, for example, we have a number 2, 5, 2, 6, 4, 3, 1, right? So what we do is that we do from the right to the left, find the first one which have first element number which have right greater numbers, that we find 2, right? And then we from 6 find which number is greater than 2, the on the rightmost, so that is 3, right? Then so step 1 is that step 1 find the first right index from right to left, find the first index as greater number from this right. So this step 1. Step 2, from index, we know on its right that the must have number greater than this plus 1, right? On its right, find the last number greater than number index. And then step 3, swap, right? So swap index, the last index. Okay, so we call this index is last index. Okay, and then step 4 is reverse, right? Reverse from index plus 1 to end, right? To end, that is, for example, minus 1. Okay, so this will be our step. So for our this numbers palindrome, right? So possibly there is a character here, right? So for this character, we don't need to care about that. And for this, if this is left part, and we just handle this left part, and then we compose this one to the right part. For example, the number here, for example, this is 9. Okay, we don't need to care about this 9. 1, 3, 4, 6, 2, 5. Right? So we use step 1 to step 2 to 4 to handle from this part, right? The left part. So this part. And then after we doing this, we just reversely to compose the right part. So if this is the length is out, right? We don't need to care about this line. It's even. So there is no character here, right? So what we do is that this is so write something like this, right? So part one, right? Part one. That is the next commutation of left part. This left, right? And then part two, that is we compose the whole string. Compose the whole string. Compose right part. Okay. So let's begin to write code for this. So what we're going to do is that we can convert this one to be child, okay, put in array, put num to child. Let's get its length into input array dot length. So we know if n is smaller equal to 3, right? We just return this number, right? Because before that should have no changes, right? No, just return empty string because say that there is no bigger one, so it will return empty string. So what we need to do is that we, for example, we have int m equals n divided by 2. Okay, so what we do is that from the now we're handling the next permutation of the left. Okay, so what we do is that we have index equals -1 for int I equals m minus 1. M minus 1. That's I greater equal to 0. I minus 1. We need to have I equals m minus 2 because we need to compare to the right. So if you have nums num I smaller than num I plus 1. Okay, so there will have index equals 5 and then 3, right? So the thing is that if after we're doing this loop, if index equals -1, that means the left part is in a descending order, so we just return any string, right? So this column case is a bit different than the next permutation. For next permutation, we need to reverse. Then what I need to do is to find the last index greater than this this number, right? So what we do is in the last index equals minus. We know at least only the right one is greater than this, right? So let's say call int I equals last index. How this plus 1 smaller than m I plus. Okay, so we'll say if num I greater than this should be none, right? This is character 1, 2, 3, but char 2 is greater than char 1, right? So we don't need to convert this to integer. Num index, then we have last index plus I. So for this one, we don't need to break. So this is step 2. step 3 is swap array index last index. And the last step is reverse array index plus 1 to n and 1. Okay. So this we recompose from the left step, right? So for the right step, the left part, for the right part, we just recompose it. So what we do is that for in the I equals x more than m I plus plus. What we are going to use array n minus 1 minus I equal array I. Okay. In the end, what we do is that we return new string array. So we need to have the swap in the reverse function. Private in the swap array in the left in the right. So what we do is that we need to have a temporal chart and close array left, and close array right. And we'll have array right close. Okay. And also this is right. And also we have reverse array right reverse array in the start in okay. So what we're going to choose while in start smaller than n, we'll have swap array start and we can then move the start and right. So we have this here. Here, right. Nice, 17. This is array. Oh, not okay. Right. This is 28 to 9. Two. So okay. So doing like this, the time complexity will be less, right? So base we just convert to this to cherry to also be O length.